All right, my friends, we are going to look at exponents today. So we're going to look at exponents like we have never looked at them before. But you know, when people say like, ooh, it's increasing exponentially, this is what they're talking about. So before we start with that, though, let's back up the train for 5 seconds and review everything we know about exponent rules. And I really hope you know all of this. I'm pretty sure I taught you this stuff in like grade 10. So we know that if we have two numbers, so I'm going to say like 3 to the 4th times 3 to the 5th, that's the same as having 3 to the 4 plus 5, right? You can add those. And that works for division too. Like if we have 3 to the 4th divided by 3 to the 5th, that's the same as having 3 and then 4 minus 5, right? So the key in this is that the bases are the same. And then if you're dividing, the exponents can subtract. And if you're multiplying, the exponents can add. Like I feel like we've seen this before. Another one that's really important is the power rule. So let's say we have like 3 squared to the 4th. That's the same as 3 to the like 2 times 4. It's like to the 8th, right? That's the power rule. And then, fractions. This is a good one. Like if we have 3 over 4 to the 5th, you can split that up and say 3 to the 5th divided by 4 to the 5th. Okay, so that's a fraction rule. We know about zero exponents. Anything to the 0 is 1. We know about negative exponents. Anything with a negative exponent, it's like an elevator and it sends it up or down a floor. So that's the same as like 3 over 1. And then there's like the radical one. So like let's say we have the square root of 3. So don't forget there's an invisible 2 here and there's like an invisible 1. So that's the same as 3 to the 1/2. Right? And it doesn't have to be, like that can be any number and so can that. I mean, most often it's a square root, but we could do that with like a 5th root, right? We could have like 3, the 5th root of 3 is the same as 3 to the 1/5. Or you could have like the 5th root of 3 squared, and that's the same as 3 to the 2/5. Okay, so those are exponent rules. All right, moving on. Exponentials. So I'm hoping you've got a sheet like this in front of you. Oh, hold on. Let me get this ready. Oh, there it is. Okay. So here's what we're going to do. Okay, so our basic parent function in an exponential function is going to look like this. It is y equals c to the x. All right, so this is different than anything we've ever done before because our variable is our exponent. All right, so usually we have a variable in our number with an exponent, but now the variable is the exponent, and c stands for constant. All right. So like an example of this would be like y equals 2 to the x or y equals 5 to the x, all right? So our base is a constant and our exponent contains the variable. Now, there's a couple important things we need to know about c. c needs to be greater than 1, or c needs to be greater than 0, but c cannot be 1. All right, and I'll show you why in a little bit. So our c needs to be positive, and it can't be 1, right? So it can be a fraction or it can be a whole number, but it needs to be positive and it cannot be 1. It does some wild stuff. So let's see what this looks like as a graph. So here's my graph, and you'll notice I have not put exponents or axes in here yet because I'll show you why in a second. We're only going to look at a certain part of the graph. So let's make ourselves a table of values, and let's work with y equals 2 to the x. That's how we pronounce that, y equals 2 to the x. So here's going to be our x's, and here's going to be our y's. And let's see, let's start with -6. So let's go -6, -4, -2, -1, 0, 1, 2, 4, 6. Okay, you should be copying this down. Now, if I do this, I'm going to have, my first x is -6, so I'm going to have 2 to the -6. We just talked about what a negative exponent does. Isn't that the same as 1 over 2 to the 6th? And what's 2 to the 6th? 64. So this is 1/64. All right, let's do the next one. So if x is -4, we have 2 to the -4, which is the same as 1 over 2 to the 4th. 2 to the 4th is 32. So 1/32. Now I just, again, I really want to point out that there's no negative here. That negative became a positive when we moved it to the denominator. Okay, I don't want to see any negatives. Okay, 1 over, or sorry, the next one's going to be 2. Good gracious, 2 to the -2. So that's 1 over 2 squared. So this is 1/4. And then 2 to the -1 is going to be 1/2. Careful, 2 to the 0 is what? 2 to the 0. Anything to the 0 is 1. Okay, now we have 2 to the 1. Anything to the 1 is itself. 2 squared is 4. 2 to the 4th is 32. And 2 to the 6th is 64. Okay, so we just went from like a real tiny number to a really big number. And if you'll notice, what do we notice about all these y's? They are all positive. Okay, so let's design our graph to work for that. So I'm going to put my x-axis way down here because I don't really have any negative y's, so I'm not overly interested in them. And then I'll build my y-axis right here. Okay, so if we're going to graph this thing, we're going to graph -6, 1, 2, 3, 4, 5, 6, in 1/64. So, basically it's 0. Then we're going to go to -4 and go to a 32nd. So, okay, there. And then we're going to go to a 4th at -2. Okay, I'm not very good at this. Then we're going to go -1.5. And then 0, we're going up to 1. And then 1, we're going up to 2. And 2, we're going up to 4. And 4, we're going up to 32. 1, 2, 3, 4. We're going, okay, way up here. And then 6, we're going up to like 64. Okay, now we've just lost control. All right, so here's our graph. And you can see that I'm clearly the worst graphing person on the whole planet. Okay, we're going to connect these. I'm going to start from this way. I'm going to go up, 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 up. We're rising faster and faster and faster and faster. And we're basically rising very quickly. This is called exponential growth. So exponential growth, let's write that down, okay, is a rapid increase, okay, a rapid increase. Do you notice the shape of this graph? I know you love it when I tell you shapes. This is often called a hockey stick. I did not make that up. A hockey stick shape. So I didn't do a very good job with the top. So this is this hockey stick shape, and you can see as it cruises along the bottom, again, it's never going to quite reach 0 because like in our reciprocal functions, you always have that 1 up there. So it's just going to kind of hug the y-axis, and it's going to just rapidly escalate, and that's our exponential growth. Now, this happens, again, when our c, our constant, is greater than 0. So this happens when our constant, is greater than 1. All right. This is the parent graph. Is there an x-intercept? No. Is there a y-intercept? Where is the y-intercept? It's always at 0, 1. Think about that, because anything to the 0 is 1. Our domain is x is an element of all real numbers, and our range is y is an element of all real numbers, and y is greater than 0, not equal to. Okay, so this is the parent function of an exponential. Of course, we can move it and do all sorts of crazy things with it, but let's just hold on that. Okay, let's look at the back side. Okay, here is the back side. I know I put 3 graphs there, but I think we're only going to use, or I put 4 graphs there, but I think we're only going to use 3. Okay, so here's the back. Let's see what happens. Remember when we said that C cannot be 1? Let's look at why, like what would happen. So if we had y equals 1 to the x, think about what this would look like if we made a table of values. We would have, like, let's say -2, -1, 0, 1, and 2. So 1 to the -2 is 1 over 1 squared, it's 1. And 1 to the -1 is 1. And 1 to the 0 is, well, it's 1. And 1 to the 1 is 1. And 1 to the 2 is, well, still 1. So if we graphed that, like, let's put some axis on here. If we graph that, the graph would be, it would just look like this. Like, it's just 1. Okay? So it's not that this doesn't exist. It's just not exponential. Okay? So it's not exponential. We also said that it had to be positive. So let's look at what would happen if it was negative. So if we had y equals -2 to the x, what would happen? We would have like xy, and let's go same thing, -2, -1, 0, 1, 2. So -2 to the -2 is 1 over -4, is that right? Or -2 squared is, no, it's 4. Okay, so 1/4. And then -2 to the -1 is, let's see, -1/2. Is that right? I think that's right. And -2 to the 0 is 1, and -2 to the 1 is -2, and -2 squared is 4. Okay, so if I graphed that, what would happen? Again, I can graph it. -2 go up for 1/4. Okay, -1 go down 1/2. 0, 1, over 1 down 2, and over 2 up 4. Okay, so is this exponential? Like, this doesn't look exponential to me. Okay, again, this is not exponential. All right, so this is why exponential functions don't include negative constants, nor do they include 1. But what we did say was okay was fractions. So, like, what if we had y equals 1/4 to the x? Let's see what that would do. So, okay, I'm going to say, again, -2, -1, 0, 1, 2. And if I did that, I would have 1/4 squared, right, under 1. So 1/4 squared is 1/16. 1 divided by 1/16 is 16, right? And 1/4 to the -1 is 1 over 1/4, which is 4. 1/4 to the 0 is 1. 1/4 to the 1 is 1/4. And 1/4 squared is a 16th. Okay, again, I have all positive numbers for my y's. So I'm going to make my axis kind of low to reflect that. and I'm gonna go over to -2 and up to 16. So I don't know, way up here. And then I'm gonna go over to -1 and up to 4. And then I'm gonna go over to 1, or over 0 and up 1, over to 1, up a quarter, over 2, up a 16th. So this time, I get a hockey stick pointing the other way. So this is exponential. Okay, it is exponential, but it's decreasing. Okay, it's not, wow, I can't spell. It's decreasing. It is not exponential growth. It is the opposite. It's a decline. So, and like this is like what we'll talk about with like things that are dying, and we also quite often call this decay, right? Because it's a decline. So the moral of the story is a fraction, a constant that's a fraction, creates a decline, which really kind of looks like a reflection, right? Doesn't it look like we just flipped it over the axis? Okay, that's it. I hope that made sense. Okay, you guys are great. Bye.